The INOUE Lab is located on the AIST Tsukuba campus. Featuring state-of-the-art research facilities, AIST is the largest national institute in Japan. You can cycle to AIST through the beautiful footpath in around 1/2 to 3/4 of an hour. This is a bit far, so you need great passion for your research. However, a hotel-like dormitory is available for international students at quite a reasonable price.
Yes, passion for research is one of the 3 requirements to enter our lab. The other 2 is diligence and integrity. If you satisfy all 3, I guarantee your success. You can talk with me frankly anytime, here, in the lab, in the canteen, anywhere about physics, electronics, living, culture, subculture, entertainment, sports, politics, or philosophy. Students who just want to discuss how to mimic our brains by physics or electronics are also very welcome.
One of the research topics is solving the problem related to the Internet of Things, IoT, which refers to our contemporary situation in which many gadgets are connected to cloud computers through the Internet. IoT is vulnerable. It is constantly under threat of malicious hacking. The best solution is to disconnect the Internet and let the edge devices think by themselves using a computer algorithm, such as the famous deep learning. Recently, deep learning defeated the world champion of the Go game. It was big news because some people interpreted this achievement as a computer finally overcoming the human brain. But deep learning consumes enormous energy compared with the human brain. Such an energy-consuming algorithm can't be used in any edge devices. In fact, by 2050, most of the world's total energy consumption will come from those edge devices. This is not surprising, but it is a severe problem. To solve the severe energy problems of our future society, the lab is trying to realize brand new low-power computation by mimicking the biological system of the human brain. Currently, they are conducting experiments to extract the habits of drawing triangles. For example, their neural network can tell whose triangle it is without using the energy-consuming algorithm.
In this lab, we design, integrate, and characterize artificial neuromorphic circuits from device to system levels. Developing neuromorphic circuits involves a variety of tasks, such as characterizing individual components, building analog digital circuits, and programming. In this white box, I programmatically built a neural network with 100 neurons. Each neuron outputs pulse signals like those generated by biological neurons in our brain. You can see the activity of the artificial neurons in this oscilloscope. For now, the neurons are implemented on a digital chip called FPGA, but we plan to replace these with our own custom-made neuromorphic devices that enable more efficient operation.
Indeed, some of their neural network components are original custom-made electronic devices that mimic biological neurons and synapses. Those tiny electronic devices are made of oxides and are fabricated in the lab's clean room using photolithography. If you are interested in electronic device fabrication, you can focus on this study. But of course, you can also choose to study both electronic circuits and devices simultaneously.
This machine is called a stepper. A stepper uses ultraviolet light for photolithography. It's the reason for the yellow light in this room. The patterns on this reticle are projected on the substrate. The resolution is around 1 micrometer.
The unique artificial neuron is made of an oxide called strontium titanate. This material is on the verge of ferroelectricity, but dropping a tiny amount of electrons makes it superconducting. If you want to study the physics of such materials more than the neuromorphic device or circuit, the lab provides another option. You can grow single crystals of oxides with the floating zone furnace and investigate the physics from above room temperature down to around 0.05 Kelvin.
Now in this floating zone furnace, I am growing single crystal. The light focuses on the feedback and the spot is melted. This region is called the molten zone. The zone moves upwards by moving the rod downwards, and the crystal appears below. You can do interesting physics measurements with the single crystal that you fabricate by yourself.
Passion for research is one of the 3 requirements to enter our lab. The other 2 is diligence and integrity. If you satisfy all 3, I guarantee your success. 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 I guarantee your success.
I'll help you to use any facilities in this clean room.